Let's take a look at this Regents question, which connects finding the roots to an equation, imaginary roots, complex roots, and how it affects a system graphically, or how it affects the graph in general. So it says algebraically determine the roots in simplest a plus bi form to the equation below. So as soon as I see the phrase simplest a plus bi form, I know that I have to use the quadratic formula. I shouldn't even bother factoring because I'm going to get complex roots. And when I factor, I don't get any i's. So I need to have this in standard form before I go to solve with the quadratic formula, which means I have to set it equal to 0. So I'm going to start by subtracting x and adding 8 on both sides, making sure to line up my terms nice and neatly. So I get x squared plus 4x plus 16 equals 0 because my right side cancels out. So that means I have a equals 1, b equals 4, and c equals 16. Remember that the quadratic formula will be given to you on tests, quizzes, midterms, finals, the Regents, anything like that. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to start by setting up my parentheses so I'm ready to go and just plug everything in. So I can plug in b is 4, a is 1, and c is 16. I have a negative 4. I'll do my radical in the calculator in a second. And in my denominator, 2 times 1 gives me 2. So remember that everything underneath the radical goes in the calculator, but not the radical itself. So I'm going to open up my calculator, open parentheses, 4, close parentheses squared, minus 4 times 1 times 16. So underneath the radical, I get negative 48. Remember that you have to break your radical into 2 things that multiply. One of them should be a perfect square. So I have x equals negative 4 plus or minus. I'm going to break this into 2 radicals. The first one is my perfect square. I'm going to make that a negative. Remember, if you don't know what multiplies to 48, you can go to your calculator, go to the y equals 48 divided by x, second graph to go to my table, and I can scroll up and down to find my pair. You want to pick the largest perfect square. So hopefully you see that 3 and 16 work. So I have a negative 16 and a positive 3. So I have negative 4 plus or minus the square root of negative 16 is 4i. Remember, if you don't remember those, you can go to your home screen, the square root of negative 16, and it gives me 4i. My radical 3 stays, divided by 2. Your last step, without the radical, every other piece, can they be divided by something? They can all be divided by 2. This becomes a 2, this becomes a 2, this becomes a 1. So my final answer is x equals negative 2 plus or minus 2i radical 3. Part B says, consider the systems of equations below. The graph of the system confirms the solution from part A is imaginary. Explain why. So it confirms the solution. So I want to first type these into my y equals just to be sure as to what they're talking about and what I'm looking at. So I'm going to go to my calculator. I'm going to go to the y equals. Put this over here so I can see it better. So my first is y1, x squared plus 5x plus 8. And then my second one's going in y2, x minus 8. I'm going to hit zoom 6. That always brings me back to my original window. So this is what you should see. I'm going to click and drag this onto my page so I have it to refer to. So what you should see is that there are no points of intersection. And remember that a solution to a system of equations is a point or points of intersection. So the graph of the systems of equations shows no points of intersection, and therefore no real solution to the system. Therefore, it confirms that the solution to part A is imaginary. Now, the reason it's confirming that, I'm going to scroll back up. If you take a look at part A, the left side of part A is y1. And the right side of part A is y2. So that means that if I were to set these equal to each other, there would be no real solution, which is true because we got an I, or an imaginary or complex solution, for part A.